Yeah, what a pest. What a crazy little pest.
This is Serious Grower Podcast. I am Anna. I'm an entomologist. I'm a scientist, and I am using this podcast to talk to all kinds of growers and eaters who are serious about their farms, their gardens, their local food systems, and I am asking, how can science help? Today's co-host is Will. I'll let him introduce himself.
I'm Will Hastings. I'm a food and ag field specialist with the University of New Hampshire Cooperative Extension based in Coos County.
You'll hear more from Will as he will pop in here and there as an expert in crop production. But folks in his county are dealing with a very unusual entomological problem, and that is a new invasive fly species called swede midge.
This came to our attention a couple years ago because we had small-scale diversified vegetable farms, different brassicas. You really notice it with things that form a crown, like a broccoli or Brussels sprouts, where we just had failure to launch. There was no head formation or really deformed heads. And we're like, is this viral? Like, what's going on with this? Something is going wrong. Then plants start rotting and you get that gross rotting broccoli smell. So it's really easy to kind of pick up on it in your field. We did a little digging, and could this be swede midge? This new invasive insect pest on the scene that's different than a lot of other insect pests. Normally up here in Coos, because we're at the top of the state, we're the last ones to get these new invasive species, because I think a lot of times these things come from south to north, right? And they work their way up. Swede midge bucks that trend. It came down from Canada into New York, over to Vermont, into New Hampshire via Coos County. Not being able to grow brassicas is a really big deal for small-scale New Hampshire vegetable farmers, because you go to vegetable farms in New Hampshire well, especially the spring and fall, but year-round, there are brassicas growing. They constitute a large part of these growers' crop shares. They're economically important. They're some of the first things to get us into the market, some of the last things off the field in the fall. So not being able to grow brassicas is kind of a non-starter, right? For many of the growers I'm working with, they are also low or no-till, as well as certified organic. You've got a few different options, right? We can stop growing brassicas for, I think, at least 3 years, if not a 4-year rotation. So stop growing the thing that makes us a lot of our money for a long time. We can rotate.
It's like a mile or...
Yeah, it's like a mile away, which many of these farms were talking about sub-half acre, highly intensive production. We can't move. The other option is come in and spray it and knock these populations down. So with these small scale, lower no-till organic farms, in a lot of ways, we're trying to fight this pest with one hand tied behind our back. So we had to look at some innovative ways of excluding this. The one that seems to be working, knock on wood so far, insect exclusion netting with low tunnels to cover these crops and physically exclude this pest. So we've got to come in, we've got to use landscape fabric or plastic mulch, plant on that. So that means if any pest gets in, it's going to drop onto the plastic and won't be able to pupate in the soil, and then that insect netting is going to keep it from coming in and laying in the first place. Yeah.
I have a lot of questions for you, and like a lot of them are like, how are people handling certain things, and like then kind of talking about what you guys need and like what kind of answers you need. First things first, because you're a horticulturist, you're a plant guy. What I don't know a lot about is all of the other things that you could mistake for swede midge or vice versa, right? So I think that maybe this goes unnoticed because people are like, oh, there's maybe a nutritional problem. Like there's other things that cause blinding in broccoli. I mean, you mentioned rotting and smelliness. But what are the other things that you might be looking for that might be mistaken for swede midge?
Yeah, it's like when we get this blinding or just distorted growth, right? I'm thinking it's temperature, maybe it's some sort of mechanical damage, maybe some sort of micronutrient issue. There's all sorts of things that we can look at, but then rule out pretty quickly. I think for new and beginning farmers, yeah, it could be anything under the sun, right? And it's not going to be obvious right away that not many things are going to cause this severe level of damage.
Yeah. I think this is something I might call up Amber and find out more about the monitoring project that UNH is pursuing and kind of figure out like where are they at when it comes to monitoring regionally, or if they're thinking about growing degree day models to predict flights. Like, is that something that would be helpful, especially for people who are using netting?
Yes, absolutely. Okay. I'll let Amber really get into that, but we've been monitoring on 2 participating farms for the past couple seasons. We've been changing out traps once a week. Hopefully with enough data, we can start building up some population trend on this and say, okay, do we have peak flights? When are these things showing up? Because growers want to know, okay, when do I need to put my netting out? And how long do I have to keep this stuff up? Is it forever? Is our farm just going to turn into biodome eventually, where we've just got one giant bubble over everything?
Right. Make sure to follow us on our Instagram page at Serious Grower to see photos of some of the damage we're talking about. We were able to catch up with UNH's IPM specialist who's been involved in monitoring programs in the state that help farmers make smart pest management decisions with common pests attacking vegetable crops and fruit crops. And she's also involved in some monitoring programs that act as early warning systems to detect new species if and when they spread into new geographic regions. This includes swede midge, as well as another completely unrelated pest species, leek moth, which is causing some grief for onions and their cousins. I will include photos of the window paning feeding Amber mentions when she references leek moth.
I'm Amber Vincasi-Vall. I'm the Extension State Specialist for Entomology and IPM with the University of New Hampshire. In New Hampshire, it's only known to be in Coos County, so only one county, but the New Hampshire Department of Agriculture, Markets, and Food has been doing a pest survey over the last couple of years. They did it in 2017, and then they had to wait a few years to do it again. But the last 2 years, they've been putting out leek moth and swede midge traps in southern New Hampshire counties and western New Hampshire counties to see if they can detect it anywhere else. And so far, swede midge is still only confirmed in Coos County.
Terrific. And do you know if the sites where those confirmations are kind of isolated? Is it you just see it in one spot, or do you start seeing it in spots neighboring? Is it something that's spreading on its own? What's your sense of that?
I can answer that a little bit. So the sites we've found it at, or suspect we found it at, are all within southwestern Coos County, kind of centered around Lancaster. That being said, we haven't looked too in depth in far northern Coos or eastern Coos. Part of that is because of the lack of commercial vegetable farms. And so this might be popping up in home grower situations, but getting thought of as something else. So yeah, we don't really know the full extent, I think, in Coos.
Amber, do you want to weigh in on that?
Yeah, I just to add that swede midge damage is very easily misdiagnosed as abiotic issues. So weather problems, frost damage, bolting in broccoli, herbicide damage, it could look like, because it's distorted growth. So it could look like a lot of different things.
Mm-hmm. Has this been raised as a concern amongst growers in the southern part of the state, or do they just have too much on their plate to worry about this right now?
I would say they're kind of aware of it, but until we tell them that they need to be concerned about it, they're probably not going to really think about it. I think just hoping it doesn't come south. I would say maybe the growers that border Coos County are a little more aware and concerned than those in southern New Hampshire.
Wow, that is a ringing endorsement for the monitoring work that you guys have been doing, right? So I know that most monitoring programs are really limited as far as the cost of labor and things like that. But in a perfect world where you had plenty of people to do the work, what would a monitoring program for this look like?
Well, probably a lot more traps and a lot more sites, especially those that are heavy on brassica production, probably starting in Coos and around Coos, just because it's a gall midge, so it's not going to travel very fast, very far, unlike leek moth, which is another invasive that has spread through the state a little faster. Really, the biggest challenge with monitoring is identification of swede midge, because it looks just like many other midges. And I am not a taxonomist, even though I am an entomologist, and I really struggle with identifying it. I've heard from some other states, too, that they think they have it, but they're not 100% sure. So they're just kind of calling it swede midge because they see midges on the trap and they see damage. And it's very difficult to identify to species.
Well, from what Will was telling me, it sounds like the damage, once you've seen it, is pretty easy to distinguish. But once you see the damage, it's too late to do anything about it. So it's a matter of detecting it in certain regions. But as far as giving people advance notice so they can take some kind of IPM measure before the fly lays its eggs, is there anything known about preemptive monitoring?
I don't know, because that is a good point. Once you see the damage, it's too late, but hopefully you can prevent it from building up in future years and in that season as well. Or if you know it's in your county or your region, or you grow brassicas near where it has been found, it might be worth implementing some of the control measures for prevention, like row covers. That's also something that we're trying to get a better handle on, is the timing of swede midge emergence in the spring from the soil when the pupae emerge as adults. And then all the overlapping generations, because they can kind of be active from May through even November. Also teaching growers and homeowners as well to destroy all their crop residue, because even after you harvest, if you still have brassicas in the field, the swede midge can continue developing in the secondary shoots, and then you're just contributing to the overwintering population for next year. One of our growers has had a lot of success with exclusion netting and plastic mulch for both weed control and to try to prevent the larvae from dropping to the soil to pupate, or for pupa to emerge as adults from the soil.
Okay. It's my understanding that these midges are easily controlled with any kind of pesticide, organically approved or not, as long as you get it applied at the right time. If you knew when to apply it, do you think that that's probably right?
Yes and no, because of where the larvae are feeding within the growing points of the brassicas. They're hidden and they're very small. And that's another reason why it's hard to detect them, because you can't really see them unless you're really, really looking for them and peeling apart the plant. It's hard to get contact insecticides to the larvae. There aren't as many organic options available. One of the best insecticide strategies is systemics in conventional production, as like a trade drench for your brassica seedlings. And there just aren't really systemic and translaminar options for organic growers.
You mentioned leek moth. I mean, what else do we need to know about leek moth? Like, it's something that's kind of in the cultural zeitgeist because it's like a new and emerging pest, right? Like, they're not related at all. They just happen to come up at the same time. What are you telling people about leek moth right now?
Right. Yeah, they kind of arrived in New Hampshire at the same time. And for quite a few years, leek moth was only known to be in Coos and Grafton counties. But 2024, we found it in Sullivan County from the New Hampshire Department of Agriculture's pest surveys. And then this past year, it was found in Merrimack County. So it's now in 4 counties in New Hampshire. And because it's a moth, it can travel further and faster. And I do expect it to spread through the state much faster than swede midge. It's kind of a pseudo leaf miner for allium crops, but it's much easier to control than swede midge. So I'll at least say that.
So what are people looking for when they might have like their first indication of leek moth on their farm?
Depending on the allium crop that they're growing, you might see window painting damage from the caterpillar kind of tunneling through the hollow-leafed allium. So they're basically leaving just kind of a translucent layer of leaf tissue on the leaves. There's 3 generations in New Hampshire, I believe. And I think the biggest concern is the larvae making their way into the bulbs for storage and affecting storage quality. Leek moth doesn't usually kill the plant, but it does affect marketability, especially for those alliums where the leaves are the marketable part, like leeks.
Yeah, so like that's a good point. Like it's called leek moth, but it impacts all the onion crops.
We're monitoring for it. It's much easier to identify because it has like a perfect white circle when its wings are folded on its back. So it's a lot easier to ID. But hopefully we'll be able to kind of predict the timing of those generations as well, so growers can get row cover or exclusion netting on, because that's really effective management method to prevent the adults from laying eggs on the allium leaves.
Well, just shifting into like what we could accomplish doing field research, especially when it comes to swede midge, we're going to be a little bit limited to what we can do because we can only work at places where it already exists.
We know kind of where it is in Coos right now, and we expect it to move eventually. Don't quote me on this, but something like 6 kilometers in like 6 years. So it's not moving fast. But if there's a lot more plant movement of like plant starts and things, it could move faster. I think for us, the biggest thing is getting faster identification and diagnostics for swede midge, because we're trapping for it, but we're not good at knowing if we found it. So possibly even finding a way to do molecular testing to just get quick, accurate diagnosis fast, and then start developing these like models, degree day models for swede midge and for leek moth, because I think one of the things that growers really want is to know when they're going to emerge, how to predict it so they can get their controls implemented, like exclusion netting or plastic mulch or crop rotation, and also the effects of weather on swede midge and leek moth behavior and flight activity as well. Like if we have a really wet spring or it gets hot sooner, like what's going to happen? Because leek moth isn't usually active, the adult, until it reaches 50 degrees. But it's like, what if it's like 48 degrees? Are we going to have a few that are coming out of overwintering and already starting to lay their eggs?
When it comes to monitoring and like having some kind of diagnostic tool, right now you're monitoring with like a lure on a sticky card in like inside a trap. Is that how you're monitoring?
For swede midge, it's the female pheromone. So we're only catching male midges, supposedly. And it's in like one of the white triangle traps.
Like a wing trap. So it's like flat like that.
Yep. And then you hang it so it's close to the top of the foliage, right, Will? Will's the one that puts them out. So
okay. So if we were to develop a trap that had like a molecular diagnostic tool, it might be helpful to have it over a drowning solution, kind of more like an SWD trap. Would that ruin your life? Would that make it easier or harder? Like, would you be willing to try new trapping designs?
Yeah, I think we would need to try new trap designs if we're headed towards this molecular analysis. I'm just picturing trying to pluck off sticky trap covered midges.
Right.
And it's hard to pull insects. I was doing it with potato psyllids, but pulling the things you need to test molecularly off of a sticky trap is not a fun step in the process.
That, and you want to change your traps out more frequently than it's probably like you'd probably want to go.
We've been doing it once a week now.
Okay. Well, yeah, I think maybe you'll talk to some people and say like where are we at right now? Like, could we validate something that like you could just pour the contents of the trap into a container and send it down to the lab to be tested, rather than you're probably like wrapping up the sticky cards and freezing them and sending them to Amber to like look at under a scope. Is that what y'all are doing right now?
If by freezing you mean tack them to my bulletin board, then yes.
However you're managing
Yeah.
that, yeah.
Other questions like, we're just trying to get a positive signal for swede midge DNA, right? If we have a positive on a trap, that's enough information for me, I guess, right now. Not getting into threshold amounts per trap. Just thinking about trying to get these midge bodies off of these traps. I'm also curious, does submerging a sticky card in a solvent render that DNA inert? How do we lab process these quicker so this is cost effective?
Quicker molecular diagnostics would be ideal because then we know for sure it's a positive. When you're looking at the sticky trap under a microscope, there's so many midges that look so much like it. And also when the tiny midge is on a sticky trap, you can't always see the characteristics you need to see. And it's not like, yeah, I'm like 95% sure this is a swede midge.
Well, I'll see if there's anything out there that's like ready to go out this year that we could compare to the standard, which is sticky trap lure you with a microscope using your best judgment, right? Like that's the standard approach right now, which is time consuming and not perfect. There are currently no plans to develop molecular tools for identifying swede midge, or at least not for the purposes of monitoring like we were just discussing. But I was able to get a hold of the director of the University of Maine's Applied Genetics and Genomics Lab. Find a link in the show notes to our full interview because Tom's lab is doing some really important work surveying for ticks and identifying tick-borne pathogens in the landscape. But he helped me understand why we don't use molecular tools for monitoring as much as I feel like we should. Yes, it comes down to money, but it's more a matter of maybe return on investment and the perceived importance of the scenario at hand. Furthermore, what really surprised me was what I thought was going to be barriers, the quality of the insect specimens that we might deliver to him, the difference between like a dried out old swede midge on a sticky card versus swede midge in a drowning solution. I asked him about both of these, and what he told me was kind of surprising and pretty cool.
My name is Tom Rounsville. I work for the University of Maine Cooperative Extension. I'm an assistant extension professor and the applied molecular specialist. I mean, we could do either. I've done both of those with aphids. So we have an issue up in northern Maine and other places as well with certain species of aphids. Often when we get them stuck on a sticky card or in a drip pan, they get destroyed and it's hard to identify positively like what species of aphid it is. Even if you're really trained in doing it, just the condition of samples arriving at the lab is usually so bad. Basically what you just said about the swede midge, where even if an entomologist gets it, the characters that they need to key it out aren't there because it broke off on the trap or they can't get it off. That being said, the amount of sample that you actually need to do a genetic test is pretty limited. We've done DNA sequencing from like larger things like single larvae of insects, or you can use like legs in like portions of a body and still get enough information, because the sensitivity of the techniques that we use are the same for when we're testing for that causal invasion of Lyme disease, and there might only be a couple of individual bacteria inside that tick and we can still pick it up. So when you have the insect, they have way more copies of their genome in just a single body part. So even if it has been sitting out in the sun or doing whatever, some of it is degraded, but some of it will still be available for whatever you want to do with it. The advantage of the liquid trap is that some of that insect will actually get sort of broken down and digested into the liquid. So we can then just like take that liquid itself and then recover fragments of the DNA of whatever was in there without having to break up and test every little insect that's in there. Versus a sticky card, I could just grab a forceps and grab a chunk off of whatever's on the card and then just extract it myself, which is the process of removing the nucleic acid, so the DNA and the RNA, from all of the proteins and body parts and things that we don't want.
That sounds so much more accessible than what we do, because sometimes you have to use solvents to like get the whole insect body off. But we don't even need solvents because we don't need the whole animal. We just need part of the animal off the trap.
Yep.
All right.
We have tick samples that have been sitting dried in jars for years, and we'll test them and they still work. So usually the thing that breaks down DNA the fastest is being wet. So the drowning traps, while it will work as long as we get them like frozen once it's been collected, it should be fine. But if there's liquid water present, after probably like 3 to 4 weeks in that trap, it would probably not work very well to preserve the samples. So we just have to create like okay, you leave the trap out for 1 week and now you put it in your freezer and then ship when you're ready. Or we could find a way to like dry it out, or sticky cards. I mean, there's a lot of different options. Best way to test it would be to just send me broken insect bits that have been sitting out and doing whatever, that you know what it is, and I'll do it blind and I can tell you what I think it is. That would be the easiest way to do it.
Because I was also thinking about if you were going to test different trap types, kind of test the human detection capability versus the DNA detection, we could have a couple of these traps side by side and test their efficacy. It would take a trained eye to be able to identify these midges, because there's going to be a lot of other species of midges that look just like it. What are some of the tools of the trade when it comes to validation?
So we'd have to validate it by making blind tests. So someone would have to be spiking our samples with the species we're trying to test and then hand it to me without telling me what's in it, and then I will try to test it back. And that's how we would determine our efficacy rates. Will we get every single thing all the time? Probably not, but depending on the method you choose, we could get pretty darn close. And that's why, again, like I'd asked about methodologies, because if you have like maybe 3 species of interest that you're trying to capture with these traps, then I would probably choose like a qPCR method. It's going to be more sensitive than DNA sequencing and more robust to those samples maybe sitting out in the sun longer than someone says they did. But it'll be limited to giving you data on, is X species here, yes or no? Like that's the data that you would get. Versus a sequencing approach would be, here's a vial with 100 different insects in it. Tell me what is in here. I can do that, but the sensitivity for certain species would probably be less. So if you had maybe one swede midge fly in there with like 99 other midges, would I be able to pick it up? If I ran the right test, yes, but it might get expensive quickly. So we'd have to determine what the right approach would be. And I wouldn't know that until I made up fake mixtures of midges and then ran them to see what I would get back. But that being said, like we can extract and develop a test for anything. It just has to be at a price point that whoever's going to be using it is going to be able to benefit from it. So that's kind of the limiting factor, and has been for a while. There aren't as many labs that are willing to just make tests for whatever. We're definitely one of them. People ask us to make tests for things all the time, but it really comes down to, at the end of the day, what people are willing to pay for it. I operate not as a for-profit entity. We're extension. We're trying to help people, but molecular biology is expensive to keep all that equipment and have it available. So when we split it up across a large number of samples, it can be cheaper per sample, but at the end of the day, the cost is still substantial, potentially.
So yes, this is a somewhat obscure and understudied species. It might be hard to find the funding to pursue a project like that, but it's not going to stop me from trying. And it also doesn't mean that it's completely unstudied. Find a link in the show notes to a video summary of a recent review paper from the Journal of Integrated Pest Management. Elizabeth Hodgson is the lead author on that paper, which is basically a compilation of all the research done in our area. Dr. Hodgson works on the Cornell vegetable team in New York now, but she did much of this research herself while earning her PhD with Yolanda Chen's lab at the University of Vermont. I caught up with Dr. Chen to see what's been going on since then. Her lab does some really fascinating work in evolutionary biology and ecological pest management and agroecosystems. And she happens to also be a leading expert in swede midge kind of on the side. Unfortunately, she had a really bad cold when I got a hold of her. So what a bench to find some time to chat with me about swede midge.
I'm Yolanda Chen. I'm a professor at the University of Vermont. We were really pleased with publishing that review article because I've never successfully kind of published previously unpublished information. And a lot of that information was from undergrads. Like if their project failed, it wasn't the end of the world, but it was a lot of information there. I've been at it for 15 years and what do we have to show for it kind of thing. Part of the reason we did it is because I was getting people contacting me in different states saying, hey, I have this bright idea to and I got a little grant to do this, like a specially cropped block grant to do this or this. And they had basically proposed to do something that we had already tried, but never published. In terms of what's been going on, one of the big challenges around deploying pheromone mating disruption, which we think is one of the most promising things, we really see that we need to find ways to prevent oviposition. Once the larvae are on there, they have kind of an outsized effect on the plant. So that's kind of what we've been interested to do, is trying to ask these different questions around the ecology and reproductive biology of swede midge. Where do they mate? Do they mate in last year's field? Is there any host-associated mating? How long are they in the soil for? Because if they're in the soil, like 99 or 100% of the pupae are in the soil, then maybe deploying pheromones in like last year's field might be more ideal. So that's a big part of the challenge, is to kind of think about this kind of sort of whack-a-mole kind of approach around managing the midge based on mating behavior.
I'm going to jump in here and point out that mating disruption is exactly what it sounds like. We're disrupting the normal pattern of mate finding specifically. So in principle, you fill a space with so much synthetic moth pheromone that male moths cannot find female moths. Therefore, female moths cannot lay eggs. A big barrier to this kind of research is doing field scale trials that really link deployment of this behavioral control to control in the field, especially limited to areas where this midge already exists, as well as realistic scales in the environment. I asked Dr. Chen about that too.
Basically, because this is not a very popular thing, we had to establish what I think of as sort of swede midge field populations. No grower is going to want us to, deploy live midges in their field. We took over some different hay fields around UVM. We've been growing canola, throwing swede midge out there and stuff like that. And so next year we will ask this question of, do we see any effect on yield? We're looking for collaborators in the region because we have a limited budget for travel and stuff. And we're looking for growers that might be interested in participating.
I will leave it there for now because the growing season is looming. Unfortunately, I don't have too much advice for Will. He's stuck with all the tools in the IPM toolbox that he had last year. He will be monitoring for adults using pheromone-baited traps when they start flying in May, and he will be providing support to his growers who are using cultural practices to exclude adults from laying eggs on their broccoli plant with netting, and will be using mulch to discourage pupae from thriving in the soil. I will check back in with Will at the end of the season to see how things are progressing. Thank you so much to all of my guests. Find photos of what we discussed on our Instagram at Serious Grower. Serious Grower Podcast is a production of New Hampshire Community Supported Research. If you are interested in becoming a co-host or would like to learn more about our mission to democratize agricultural research, visit our website at nhcsr.org or come over to our YouTube channel at NHCSR, where we are sharing insights from the agricultural research community, and we'll be vlogging about our research efforts on the farm. You can support this work by liking and subscribing, and even better, consider joining our Patreon community.